The History of Antibiotics by Jaclyn Prillaman. Have you ever been sick or had an infection? Unless you're superhuman, then the answer is yes. More than likely, anyone watching this presentation has taken antibiotics at some point in their life to fight or treat an infection. Many people around the world owe their lives to this discovery. Antibiotics are used to treat bacterial infections. Originally, an antibiotic was a substance produced by one microorganism that selectively inhibits the growth of another. Synthetic antibiotics, usually chemically related to natural ones, have since been produced that accomplish comparable tasks. Antimicrobials have been in use for many thousands of years in a variety of forms. In this presentation, we'll trace how we have moved from ingenious uses of materials available in the environment to the chemically engineered ones capable of saving the lives of millions of people per year. There's strong evidence that herbs, honey, and even animal feces have been used for their antimicrobial properties for millennia. Modern medical scientists still use honey in chronic wound management and combating infection. Herbs like sage and honeysuckle contain compounds that directly deter bacteria. Even some more modern antibiotics may have been available in ancient times. Traces of tetracycline have been detected in human skeletons excavated in Nubia during the Roman occupation of Egypt. The origin of tetracycline in these skeletons remains a mystery. One of the most successful treatments was the topical application of moldy bread, with many reference to its beneficial effects from ancient Egypt, China, Serbia, Greece, and Rome. The theme of the benefit of moldy bread on the human body has continued over the years. John Parkinson published his book Theatrum Botanicum, which can be translated as The Theatre of Plants, in 1640. Parkinson was an English botanist who at one point studied the medicinal effect of plants on the human body. He referenced moldy bread and its effects on infected wounds in his book. The discovery of bacteria by Anton van Leeuwenhoek in 1676 kick-started the study of bacteria. Leeuwenhoek's discoveries paved the way for Robert Koch and Louis Pasteur, who were able to establish the association between individual species of bacteria and the diseases they cause. The spread of gonorrhea and syphilis prompted more experimentation with possible treatments. Heavy metals such as arsenic, bismuth, and mercury were all tried. Sometimes the symptoms improved, but the side effects were worse than the disease they were treating. Hyoscyanes, discovered in the 1890s, was the first antibiotic to be used to treat human infections in hospitals. Emmerich discovered that the green bacteria isolated from a patient's bandage inhibited the growth of other microbes. They grew the organism in batches to be used as medicine with mixed success. Ehrlich's early interest was in developing stains for the histological examination of tissues. He noted that some stains were toxic for bacteria. Silvarsin, an arsenic-based chemical discovered in 1909, proved an effective treatment for syphilis and was probably the first truly modern antimicrobial agent. Alexander Fleming discovered penicillin in 1928. There was great potential in it, but there were significant challenges translating what could be demonstrated in the lab into medicine that could be made widely available. He tried to attract the interest of chemists over the years. Howard Florey and Ernest Chain shared the Nobel Peace Prize in Medicine in 1945 for the development of penicillin. It was Florey and Chain who actually made a useful and effective drug out of penicillin, after the task had been abandoned as too difficult. While Fleming was trying to purify penicillin in Germany, scientists at Bayer were following Ehrlich's lead and exploring the antimicrobial effect of dyes. Sulfonamide had been synthesized in 1908, and by combining it with a dye in 1931, Prontazil was produced. A boy dying of staphylococcal septicemia was given the drug with success. Antibiotics in World War II. A total of 21 U.S. companies joined together, producing 2.3 million doses of penicillin in preparation of the D-Day invasion. Penicillin quickly became known as the war's miracle drug, curing infectious diseases and saving millions of lives. The best sources of new agents was from other naturally occurring microorganisms in soil, so a worldwide search began. Resources were limited, but Eli Lilly had the bright idea of asking Christian missionaries to send back soil samples from every exotic place they visited. Antibiotic resistance occurs naturally, but misuse of antibiotics in human and animals is accelerating the process. Antibiotic resistance is rising to dangerously high levels in all parts of the world, threatening our ability to treat common infectious diseases. There are promising strategies to combat antibiotic resistance. These strategies aim to prevent infections from occurring in the first place, to discover new ways to attack microbes in a manner that does not drive resistance. Infection prevention ultimately eliminates the need to use antibiotics.